All right, this video is about cooling towers. This project is an 8-story building, has approximately 150 heat pumps throughout it. The cooling towers are um, part of the heat pump. They're the cooling element for the heat pump water loop. They are Baltimore air coil counterflow towers. Druid Modular is the rep for these. So how this works is when we need cooling for the system, the cooling towers act as that cooling property. Basically, they cycle that flow of water through the coil here, and what happens is that there is a sump full of water at the lower portion of this cooling tower. This pump takes that water, shoots it up this riser, and there's a series of sprayers here that spray down. These are counterflows, not crossflow. So what that means is crossflow would be this direction going through. Counterflow is up and down. So as they spray down, um, these fans here up top are drawing in air and pulling it up and across. So it is a counterflow unit. And basically what that does is spraying that water onto it is going to get the heat removed required to cool that water down. So in cooling season, we utilize the cooling towers. In heating season, these cooling towers get shut down, the sumps gets drained out, these two units get winterized, and then they're relying on, in the basement of the sub-basement, heat exchangers, which are steam-driven heat exchangers, which they'll use the steam as the heating property to heat the heat pump water. So anyways, let's take a look. I'll go into these cooling towers here on the cooling portion of the heat pump loop, and then I'll go down to the sub-basement. We'll talk about the heating portion. So again, this gets back to my style and adding the schematics and trying to make a skeleton of the project for our installers so that they can grasp, the full scope of what we're building. Makes it easier to understand what's happening and what we have to do. So here we have just our supply and return going through the coil on this heat pump loop. We have, like I said before, that there is a sump at the bottom of the cooling tower here, which is what this pump draws to spray over the coil to cool it down. So this blue line here is our makeup water line, which if the water level in that sump gets too low, it will add more water to it so that it never dries out. We have a sump drain, which is this purple line here. So at any point, as part of the winterization process, we'll empty that sump through that line, and that goes to a roof drain on the roof. The yellow line here is if there were to have a situation happen where the makeup water for the sump were to continually get dumped in there by mistake in some way. Maybe the control valve was stuck or something like that. This would be an overflow line. So if that water rises too far, it will just relieve itself to that same roof drain through this line. This project did have us heat trace the heat pump loop water, because even when this unit is winterized, facilities elects to run the heat pump water through that coil anyhow. So that did get heat traced. All right, so for chemical treatment for these, this is something that I made up kind of on the fly here. We have our controller board here. So we got our 110 power, the controller board. This is our flow meter float. So basically that will tell that controller that we have flow through here. And then these two right here are sampling ports that tell the chemistry of the water back to the controller. And that will send signals to the pumps. So there's a pump shelf with 3 different pumps serving the inhibitor, non-oxidizer, and the bromine, which will, that controller, obviously self-explanatory, but controls how much chemical gets added to this loop. And every so often, this blow down valve, this solenoid valve, will blow down to drain as well. So how does that water get propelled? That comes out of here. So when we have this sump full of water and this pump draws it to push back up to the top for the cooling, that will grab the water from the sump here. We'll add a tap on the discharge side of that pump, which will then push that water down through our chemical feed station where it can get monitored for its chemistry periodically, and we'll send a signal on what we have to inject into that return line back to the sump. So that in a nutshell is what is going on for the cooling tower. Now, so I'll go down to our supply and return risers. This is one singular stack. And on each floor, this heat pump loop water serves heat pumps on each floor. Like we talked about, I think there's about 150 on this project. So on each floor, approximately 20 or so heat pumps is the loop. So I'll cruise down to here. So here's our heat pump loop mechanical room system. These pumps were also B&G pumps supplied by Summer at Frank P. Langley. All right. Okay. So we talked about before, the cooling tower serves as the cooling means for the heat pump loop water. Down in the sub-basement here, the heat exchanger acts as the heating element. So when we're winterized up top, when we're in heating season, we need that water to get heated up. So we've got the steam supply to this heat exchanger. We got a 1/3, 2/3 control valve system. So that will heat this bundle that has our supply and return on the heat pump loop. So that will act as the heat element for the building in the wintertime. So as a part of that system, we have 2 smaller pumps to push through the heat exchanger, and then 2 larger base-mounted pumps. And it's not represented well, but these are 2 large base-mounted 8-inch flange pumps, and those are what push the stack in the floors. The heat pump to all the heat pump, or the heat pump water to the heat pumps on all the floors. So there is a few things here. So we have air separator with a domestic water makeup in the event that water pressure dropped to some extent. This domestic water would add water to that system. There's also a chemical feed tank here, which we will treat the water as required. This allows us to put chemical into this tank, and the flow of the system will push that chemical into the system to treat it. There is a solid separator, which is pretty typical for a heat pump loop. which pretty much is an extra layer of protection that it's a bag filter that'll catch anything in the system to try to protect the equipment long term. Expansion tank acts as the bladder for the system. And that is about it for the hydronics on this system. So again, to recap, rooftop unit is the cooling means, hence the cooling tower. In the sub-basement, we have the heating means, which is the steam-driven heat exchanger. Thank you for watching. Let me know if you have any questions on this. I'd be glad to explain it. Thank you.